G'day guys, just having a look on LinkedIn. I hardly ever look, but yeah, I've been on this since it first started many years ago, but I don't use it. I've never paid membership or anything on it. And yeah, but what I've noticed, I was just having a bit of a cruise. I was looking up some information on another company, but I just noticed there's all these Minelab jobs. Here, look here. As a mechanical design engineer. These are all in South Australia. Senior mechanical design engineer. Project manager. Again in South Australia. And we go down here. And, where is it? Well, here we are. Manufacturing test technician. Minelab in South Oz. Electronics engineer at Minelab in South Oz. And maybe that's the same again, the mechanical design engineer there. So there's 5 jobs there. And we have a look, and this gives you a bit of insight into what's happening and what's coming up. Let's have a look. Let's have a look at view job here. Look at this one, mechanical design engineer. You know, about the job. Yeah. So basically, you know, you don't want to read the spiel of the company, but the interesting bit is, what will you be doing? The successful applicant will be responsible for mechanical engineering, product design, and drafting input to Minelab projects. You must be able to carry out mechanical design and create specifications to projects. Please don't make any more boat anchors. That's my input. You know what I'm talking about. Super heavy detectors and super heavy coils. Lighten them up, boys. Okay. Generate conceptual design sketches, you know, 3D, CAD data, 2D, what else here? Yeah, research, evaluate, and select appropriate materials. So they want to improve on their materials, I'd say, because they're not saying that means, in my opinion, that you're not happy with what you've got, and you are looking for better. Or maybe you are happy, but if there's better stuff out there, you want to get your hands on it. Right. You need a bachelor's degree in mechanical or mechatronic engineering. Extensive experience in product design may also be considered. Well, I think that might be mandatory, actually, in my opinion. So yeah. So knowledge, experience with plastic components, design, injection molded, extrusion, and vacuum formed. With composites experience, desirable. So maybe they're going carbon fibre on some of their new stuff. Yeah, die casting machine, steel, yeah, so the benefits and culture. Yeah, they got a subsidised cafe and a gym and a tennis court and basketball and games tables. Sounds a bit like one of those big California tech startups, doesn't it? A little bit. But that's not the job that interests me, that one, the mechanical design engineer. Then you got the senior one. Project manager. This might be interesting. The project manager job. Okay. Where is it? About the job. See more. See, this gives you an insight as into what the future holds, what they are up to. Yeah, okay. What will you be doing? Engineering, design, and innovation. Okay. Okay, basically coordinating and prioritizing project activities from different engineering disciplines. So you have to be a jack of all trades within reason, while managing risk, schedule, and budget. Okay, our projects give you the opportunity to nurture products from the basic requirements through to manufacturing and shipping. We have great teams that provide expertise, but we need someone to help bring all this together and enhance the project capability of our development programs. Okay. So basically, you got to know everything, more or less, within reason, of course. Yeah. So project engineer. But the one that interests me is the electronics ones, of course, which are down here somewhere. We don't want that one. We don't want that. Here they are. Manufacturing test technician. Let's have a look. Okay, what will you be doing? Right, just have a look at the key responsibilities. Include provide general technical product support to the manufacturing personnel to facilitate the maintenance of, and where possible, the improvement of product quality and throughput. So they want their quality up and they want to put more detectors out into the market. That's what that says, in my opinion. Interface, in other words, talk with design engineers to resolve product technical issues. Implement test and design change into production, preferably not in the middle of production. Perform test equipment maintenance and calibration processes. Construct test equipment for improvement, production capacity increase, and redesign projects. This is telling you something, isn't it? Monitor and resolve production test failures of both equipment and product. Debug and repair electronic test equipment and product. Collaborate with test engineers to construct test jigs and fixtures. Maybe using Hall effect devices. No, I just put that in there as a joke. Install and commission appropriate facilities, including test equipment, jigs, and fixtures. They looks like they're going on a big move on getting some techo people in and new projects on the go. That's what that looks like to me. Yeah. So, and then they want the electronics engineer. Let's have a look. This gives you some insight as to what they have up their sleeve and what's on the go about the role. Let's have a look here. Key responsibilities. New product design and development from concept to manufacture. Engage in detailed electronics design and development in collaboration with your project team. Work with microcontrollers and FPGA, ADC, God, things I've been talking about recently, power supplies, battery and wireless technologies, probably Bluetooth 5.3 we're up to now, 5.4. Integrate and test prototype detector systems with other engineers. So that might be some, field testing, possibly, or you're stuck in the lab with a bucket of dirt. I don't know. Collaborate on research projects to develop and improve new ideas. God, they should just ask me. Provide electronic production support for existing products. Okay. You'll need a degree or higher in electronic engineering, embedded electronics design. So, basically, it's called, we want someone to build a metal detector, more or less, but you will have support as well. So, we can look at this from a number of angles, and this is only my opinion. Is it that they have new projects on the go? It seems like it. Has it, or is it that they've had loss of staff, possibly, need to replace some? Or who knows? But it gives you a bit of insight. They got things on the go there, and they looks like gearing up to make more, faster, quicker, and all the rest of it, and improve the quality control. All under the banner of all those jobs there. I think there's five of them in the last week. There's probably a lot more too. It's really, I tell you what, in this game, it's really difficult to get hold of people that know what they are doing. Not just straight out of university graduates who don't or have yet to live in the real world of manufacturing or designing. Can do it all on a computer and paper, but falls over in the real world until they've got a few years under their belt. But yeah, there we go. Minelab metal detector, South Africa. Okay. So yeah, that's there's probably more there as well, but yeah, that's very interesting, I would have thought. Okay. Detectors. How about we go into issues of detectors? Oh, I think I might, oh, I've got this on the front camera, damn it. Okay. Well, I don't know if you'll be able to see anything here. Oh, I've got my DetectorMods t-shirt on. I haven't worn it for a while. Thought I'd give myself a plug. Yeah. So what I was going to talk about, this might be way off the reservation for people, but I've been looking at all the limitations. Like I always look at the limitations in detectors. And the biggest limitation in all our detector designs, I mean, not commercial designs or anyone's designs, limitations, what really affects the detector? And number one culprit everywhere is capacitance. And capacitance, I mean, it is acting as a waveform transition, slowing down device or squashing it out altogether. Especially small weak signals, very fast decays, or just borderline detectable. You throw a heap of capacitance on the input or signal lines, and that signal's not there anymore. You now have not got what you're looking for. Always the issues: capacitance in the coil, capacitance in the coil cable, capacitance in the active switching devices, capacitance all the way through that circuit, capacitance in protection diodes, not that it's much, but it all adds up, and op-amp input stage capacitance as well. And throughout that, we can throw a handful of inductance in there as well, which if you have enough of an inductive path all totaling up, it's all in series, it all adds together, you start to slow things down again. So capacitance seems to be the biggest issue, followed by the inductance, even tracks on the circuit board. And you know, when I used to do RF stuff years ago, I had ways of reducing inductance of a signal line, because it was all very high frequency stuff. It's like very high frequency, I don't know what, starting at probably, I don't know, probably starting at about 1.8 gigahertz all the way up, you know, to 36 at that time. And yeah, we used to do all sorts of funny stuff with circuit board tracks, and used to use Teflon boards and very, very skinny 1/32 of an inch Teflon board and stuff like that. Or was it 1/64th? No, it might have been 1/64th of an inch. Yeah. All this sort of paper thin stuff and all the rest. But just thinking back to all that stuff I did years and years ago in the RF field, you know, just then looking at, well, metal detectors are basically, you know, glorified AM radio transmitter. Bit of a slug of a thing, not very fast, not critical, as in transmitters and receivers in that regard, but for very low level signal detection, yes. Been having a look at some different technology. I actually God, you're going to think I'm bloody mad, but I was looking up on something called quantum tunneling, of all things, and I was looking at more stuff than that as well. There's lots of ways of negating effect. The other issue too in a lot of these devices we use is a capacitance product. We call it the Miller capacitance or Miller effect, and I've mentioned it before that the initial capacitance there wants to slow things down, and it just causes issues. So you bungle this capacitance together and look at your switching speeds, and I tell you what, from the coil to it going into your first input stage op amp, I really think that half your signal's gone out the window. I really do, especially like very weak signal work. You lose half of something that's hardly there. It's not there anymore. It's in the noise, and it's a real issue. So we need to get rid of the noise, get the noise out the system. Really, you want to come up with a coil that has no noise as well. It's not even affected by EMI at all. This is something that can be achieved. It actually can be achieved, by the way. There's ways of doing it. And it gets interesting. I can't say too much about it. Probably just saying what I did will throw people onto the path of looking at things going down that technology path. But good on them. I've already done a lot of study on this stuff, and I think that, oops, we kicked the tripod over. I think it's worthwhile investigating further, and across the board. I can't do it all. I'm just one person. But there's a lot of people out there who may be interested in having a look at various attributes of devices. By the way, I've got to tell you the story of the 2SK1334s that I found out weren't 2SK1334s. The old rub the number off and we'll rewrite the number on there. Well, I said, how far out of spec are these things? Because what I did when I actually got them, I turned the thing on, I just powered it up and stuck 10 volts or whatever on the gate, and I just measured the drain source, and my God, it was really low. I said, oh, that's got a lot less on resistance than a normal, Hitachi or Renesas, or whatever they call themselves, which they don't make these transistors anymore, which is a bit of a problem now. I thought I had a supply of them. I've still got a few thousand, but I wish I had an endless supply for reasons that'll become obvious probably over about the next year. I'm going to put a timeline of a year on this, but anyway, so yeah, I said, oh well, very, very low. And I said, just as a matter of fact, I wonder what the gate capacitance is. And when I checked the real devices, the gate capacitance to the other or drain or source or both together, just in an off state, was 80 picofarads. They're spec'd at 72 or something, but 80, yeah, okay, whatever. I might have had the leads. No, I allowed for the leads too. I allowed 10 picofarads for the leads. And I said, okay, that's interesting. I'll try one of these other ones. We'll just have a look and just see how far off the mark it was. And I put the capacitance meter on the thing. It was bloody 340 picofarads. I said, no wonder the thing fell over. I actually turned it on and in a detector, switching it because it was quick and easy to do. And it didn't look good. It didn't look good at all. Not a good replacement. It will work. Those transistors I got will work on any old GP, but you need to run a gate driver buffer, basically a totem pole output stage. because of the BC857 and the whatever it is, the thing that drives it. It doesn't have much current output. The what the hell is it called? ADG 333 or something, whatever it is. Yeah, it just doesn't have the oomph to drive big gate capacitances, and yeah, noise, distortion, ramping of gate voltage while signals coming in. I wonder what that does. Anyway, completely stuffs up the dynamics of it all. Can't do that. So that throws me back to the way Minelab have done it in the past by using, going into dry throat, too much talk. Now I know why everyone does talking has a glass of water next to them. What I was thinking is that even though the blocking devices, the two MOSFETs that stop the transmit drive voltage going up the Wazuki of the input stage, and the other one, it basically stops the clamped flyback going up the poor thing as well, causing a lot of smoke. Those devices, I mean, it's a good way of doing it. It's better than a 1K resistor and a bloody signal diode, how everyone else does it. Just I always, I don't know if people understand, but you look at people and they're out there and they go, you know, we're going to put a really low noise input stage in. You know, we're going to use well, you know, I know people who are using LME 49990s when they were out, no longer made as well. Very low noise figure, 0.75 dB down the low end of noise. Yeah, ST or Thomson, this used to be Thomson Semiconductors used to make them. I think National made them and got taken out. There's a lot of, you know, chop and change in that industry. And, you know, they go, oh, you'll put these really low noise devices in there. And you then, you know, stick a diode around the wrong way. So it's just resistors feeding into the diode drop to ground. I'll emphasize that again, which is also a source of noise if you don't do it properly. And what is the noise figure of a 1K resistor? Go look up Stefan Boltzmann's constant, 1.38 to the -7 something or other. I can't, that's years ago since I did that sort of stuff. Or actually, I might have been mucking around with it the other week. And it might be up on my board here, is it? I have got it there, but I can't remember the numbers for it. Yeah, basically it's just noise. Everything makes noise. If it's got heat to it, it makes noise. Even an ice block makes noise, believe it or not. If you want to go into, you go and read up on that stuff. It'll make your brain liquefy and run out your ears. But everything generates noise, and you start heating up devices and a 1K resistor into a diode, and that's our front end. And after that, we're going to put a sub, you know, 1 nanovolt noise figure device there. I mean, I can explain this really simply. It's this. It's completely stupid. It's pointless. It's beyond the joke. You can shove anything in there. God, you know, you probably put a, I don't know, I can't think of any horrible op amp I've used lately. Put an LM, 741 in there, probably make no damn difference. But people don't realise, and they do all this weird stuff, you know. A lot of people don't even know what base spreading resistance is and why it's important in front end designs either. But anyway, won't go into that sort of stuff. But there's so much areas to work on to make better technology. And imagine if we can get rid of all the losses. Okay, give you an example. I think people already do this, but I came up with this 15 years ago. Now, I think a French company does it, but I'm not 100% sure. The novel bit is not putting a preamp in the coil. That's not novel. I mean, that's simple to do. And we can actually get devices made. We can get chips made to our own specification if you want to pay out for them, but you can. You can put a whole preamplifier in a chip, do what everyone else does, and stick it in a ferrite tube. Not that you really want to do that particularly. And you could power it. You can easily power it by taking a sample of the flyback voltage, or if you want to get really clever, you can actually just take the transmit power, just siphon it off. And if you're using, really efficient new technology, it's only going to draw probably about 3 milliamps, 4 milliamps or something. It's no big deal. It's not going to have any effect on power output and that. And what you then want to do is you want to get rid of all your capacitance. Shove it up an optical fibre, okay? So you get your receive preamp in your coil, run your normal way. Don't do it. Don't do it. Don't put the transmitter in the coil. Don't do it. But run your normal coaxial line or twisted pair or whatever you want down to the coil, right? Don't use your transmit coil for receiving. Put a separate coil in there on a separate preamp, so you're not going to hit it with lightning all the time, flyback. But sample the flyback, just very small, tiny rectifier, small capacitors. You can just get some ceramics. You get things that are pinheads, 100 microfarads, pinhead capacitors. There's ways of doing it, and do your amplification directly off another winding. You could do a DD, you could do a double D, you could do all sorts of funny balanced things and nulled out coils. There's lots of ways of doing it, and just convert it into an optical output. Now, is there an advantage? Yes, you're going to have to buffer it in the coil and drive the signal on the optics. The first thing is there's no loss. Well, there's a little bit of loss in the optical fibre. You're not going to measure it, but there's no capacitance. There's no inductance. It's a damn good idea, and I would say that obviously it's a no-brainer. I don't know if anyone's done it actually. Actually, I think I'm thinking about the French company, and what they did is they put a radio transmitter on the coil to a separate receiver on the detector. And in my opinion, that's got knobs on it. But anyway, you could do optically. I'm not an optics expert. The only thing I've ever done with optics is laser transmission, when we used to just use physical choppers to send Morse code 25 years ago, just mucking around. Yeah, but stuff like that. Now you can do it with digital choppers, but we didn't have them back then. We had to make up little 2 blades it was, and it used to be covered, and every so often you'd work it and adjust the speed, and it would go dot dash sort of thing. It's just light, and anyway, very crude stuff, but we used to do it hilltop to hilltop and just muck around, sending light signals and just code, which probably no one could intercept. Anyway, digressing. Sorry, not going to talk about optics, except for as an idea for a coil. What do you think of that? I think it's a good idea. It's probably well worth looking at. You can run super high data rates up optics, but what can you put in a coil? Well, first of all, don't think outside the box. A coil doesn't have to be a pancake. A coil could be a hunchback of Notre Dame. It can have a lump on the back of it, can't it? Right? Or on the side of it, and it doesn't have to be that. Why not make it like that? Or make your coil like that and put a little box with your electronics on top, and get it away from that intense electromagnetic pulse and the ground. Wouldn't that be smart? But I don't know. Why don't people do it? Keep everything down, where all reactive to everything in the ground and back to itself. And there's just tons of stuff you can do. But anyway, maybe I should have shut up about that and kept it quiet, because now you're going to see super fast, very sensitive detectors come out that, are an order of magnitude better than the previous versions, and it'll all end up in the patent office. So first in, go for it. I don't care. There's other things much better to do at the moment than that. But it's one way of doing it. Maybe I should quickly make drawings and, body of claims and put it all up on the internet. Oh, it's already on the internet. But there's just so much things you can do. I was just looking at the design. Sometimes you look at something and you've looked at it for years and years and years, and you just take it for granted that is the way it works. And no one's ever gone, what about if we did something radically different and went way over here or way over there or whatever, and come up with a new concept? Like, it's one I came up with a while ago. It was a fully floating, as in not connected to ground or supply, front end. Basically, everything was done with power supply, was little transformers and that was going to be optical output too. So you could float the whole thing and have no reference to ground. Great for isolating, getting rid of common mode interference. Make a fully floating differential front end, differential coil setup and shielding and the whole 9 yards. And you'd say, well, what's EMI? EMI don't exist no more. There's a heap of stuff you can do. I've dabbled with a lot of it, but like I say, I dabble. Some other project or something pops up, and here's my arm on the workbench. It goes across like a big wiper blade, and it all goes into a box, and I don't touch it again for months and months and months. Like, I've got that basically the guts of an SD2000 running on a Nucleo board. All the timing functions, everything all switched. Get a Nucleo, put all this stuff around it, you've got an SD2000, well, you've got a metal detector. A basic metal detector with manual ground balance, but you can incorporate automatic ground balance into it. That's not hard to do. And with a bit of luck, Carl Morland over on Geotech will have his third book out. He said before Christmas, but don't hold him to it. If you ever go over to Geotech number 1, just 1, not ONE, 1, just 1.com. Have a look over there. Join that forum because it's got a lot of information on metal detectors, technical stuff. Find out where the forum is on his book. I left him a comment, basically, hurry up, and tell him to hurry up and finish it, because there's the first edition, then the second edition. The second edition's a good read for anyone who wants to know how all this, how metal detectors work. It even goes into programming and doing a PIC chip for a metal detector. So the third one might be even better still. He's going to, for memory, he's going to do a lot more on coils. So that might be interesting to you guys if you want to know more about coils, making your own coils and that sort of stuff. And yeah, go over there, join, and yeah, tell him to hurry up. Probably watches this and probably have a go at me. But yeah, the second edition book. I'll get to tell you this too. What happened to him? Because when he did his book, he did some in digital format. Big mistake. Well, what do you think happened when it was done in digital format? It got copied by every Tom, Dick, and Harry, file server type advertising site, and people just downloaded it for free. So that wasn't very good. So this time he's doing it in hard copy only. So That'll slow things down. So if you want it, you better go and keep an eye on that and put your order in, basically. If I don't know if he's taking orders online, but I got my eye on it for when he's finished that book. I'm in there. I want that book because the guy worked for White's. He knows a lot about detectors, so be very, very interesting. Plus, he's an engineer too, so yeah, he knows a lot. He knows quite a bit, so it might be worthwhile. Might be able to get some really good pointers out of his book, the 3rd edition. I'm not sure if George Overton's writing it with him as well. It's another fellow who knows quite a bit about metal detectors, and I think they co-wrote the previous ones, but I'm not sure this time around. I didn't ask, but we will find out when the book comes out. It'll have his name on the front, or it won't have his name on the front. Anyway, enough of that. Now, seriously thinking, guys, I've been seriously thinking about all the modifications on the detectors, and there's 2 schools of thought here that the mods I do. There are 2 camps of prospector. There's basically the full-timers, and there's basically the part-timers. And in those 2 camps, the full-timers know what they're doing. Part-timers don't. They don't know everything anyway. Know a bit, don't know everything. And I was thinking about with modifications. Like there's people out there who I know are full-timers, right? And they go for big, deep gold. And we put stuff on their detectors that will greatly enhance performance for whatever. Big, deep gold, or if you want tiny, 0.0025 bits, which I think is a waste of time and effort. But these guys who are really into it, they want the best stuff. They pay top dollar, and they get educated in what does what, and they grasp it because they know it. They just know how it all works. Then if I do that for someone who's a novice, you never hear the end of it. The detector doesn't work. It's noisy. It won't pick up small gold. It won't ground balance. All this sort of stuff, because with a lot of knobs and controls and things, you can, you can't just go and stick the V8 in a mini minor and I'm going to go and do drag racing. No, it doesn't work that way. You've got to understand things. And I've always said this because it always rears its head that people have, gone off and done something. And the reason I'm bringing this up is because of that phone call. The phone call. Ray, the phone call. I was talking to Ray about someone had a modified detector, and like I say, it wasn't done by me, and like was stated that when the gain was turned up, the detector went as quiet as a mouse and desensitized. Now, imagine being a newbie and get your detector, you fire it up, and you go, whoa, I'm going to increase the gain. And you increase the gain, and the detector goes quiet. And you go, wow, that's fantastic. And you start going detecting. And after about, 3 months, after 3 months, no, not that long, hopefully, 3 weeks, 3 days, whatever, you realise that you throw your car keys on the ground and you go over it and you can't hear them because the detector's been desensed. That can happen. It can happen. And that was the biggest problem, like I've said before, with some of the modes on detectors, that you can crank the absolute hell out of normal timings because you've got a good spacing between after the transmitter turns on, nothing happens here, and then the receiver turns on. The other ones, they're crammed in here, and if you run too much gain, you just don't get enough ground signal decay, and also just the capacity of effects in the whole system. If you want to clock it faster, it just gums up. It's like you haven't. It's the detector version of you've eaten tons and tons of carbohydrates and no fibre or whatever, and you're all gummed up and you're reaching for the laxets. The poor detector is in the same boat. It can't unblock all this crud that's sitting there, basically coming in, high frequency noise and all this, sitting there on the input of the op amp, jamming it up against the rail, either that one or that one, can't go anywhere. There's no headroom for anything else to measure anything. It just sits there and goes quiet because nothing's moving. You've got to be careful. You always test it, you know, always test it on some small piece of metal. Is it working? Like, and so many people, they have the mono. Oh, the mono is the best coil. And what do? They hit the damn thing into cancel mode. All the detector's quiet and off they go. They don't realise it's in cancel, and it's happened to me. And I've done it and I've gone, why is the detector so quiet? You know, what's going, oh bloody hell, it's in cancel. You know, and I've seen people make stoppers up. They get a piece of metal, they take the nut off, a little, someone's going to make this, right? Because there's still plenty of 45s and 5s out there. But they make a piece of metal with a hole drilled through it and it stands up. And it basically goes under the nut, tighten it up, and you can't put it into cancel mode. You just can't do it. It's blocked from doing that. And what a great idea, especially for someone who's new at detecting. So you can't do that crummy mistake. You know, you can block off all sorts of switches by doing that, so you don't make a mistake. You know, if you're in mono mode and you flick it into double D, it doesn't care. You're just using one audio. Audio. It is AD797 is an audio op amp. That's what it's designed for in those detectors. But anyway, just using one input channel rather than two, and because there's funny stuff that goes on. In a lot of cases, you don't get your 3 decibels gain, or a little bit under 3 decibels, because you always lose a little bit. But yeah, when you have 2 into 1, you should get 3 decibels less noise. But everyone tells me it doesn't happen, and they all detect, which it's quite funny. They all detect with mono coils with the detector switched into double D because it's quieter. Ah, dear me. Ah, dear me. As that professor used to say, why is it so? Why is it so? And then you go on his blackboard and draw it all out. But I know why it's so. It's because there's inconsistencies on the 2 inputs and on the outputs of the inputs. Anyway, before it goes into the integration. But yeah, so it's meant to be like this. It's like that. Anyway, you'll work it out. And it's known as well. So there's plenty of interesting stuff. So anyway, about detectors, I really think that for a lot of the modifications on the more modern detectors, depends how competent. This is where there's so many different. Every individual's individual, and you need the competence level, and it's like, you know, some people, you know damn well, you say, I don't really want to do this because it's gonna be an education learning curve like this, and other times it's smooth sailing. So yeah, don't blame the detector, blame the operator. It's usually something weird. And as a side note, not mentioning any names here, but if you watch the videos, you'll know who you are. David's dealing with this one. Had a detector, it was noisy, and given a certain time period, the detector goes crazy. Screams when you do a basically, a automatic tune on the detector. Obviously, it's a GPX 45 or 5 or something or other, or maybe it's might even be a GP. But could be anything. We'll throw it like that so no one narrows anything down. And it goes haywire. And it's very susceptible to EMI and all this sort of stuff. Anyway, I've had it here. David's had it at his place. You just swap out things that could possibly cause that to happen. And the guy had it out. He said after a certain amount of time, did it again. I got it back here. I pulled it apart, stuck it on the bench, and let it run. And quiet as a mouse, purred away beautifully. Get in there, muck around for switches. Nah, no problem. Tap the circuit board. Tap, 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 bang, bang, bang. Nothing. Heated up with the hot air gun. Nothing. Just a normal noise you get from heating up some of the op amps in there. But nothing. Stable as a mouse. I mean, well, it was a dead mouse. No, it's stable, quiet as a mouse, not stable as a mouse. Mouse isn't stable, Jesus. But that's funny. Anyway, I tried everything to try and make this detector go nuts. I checked the wires on the plug, the old, it wasn't soldered properly, no, perfect. David even replaced the back Mylar connector. I went over the whole thing. I checked everything, hot, cold, extended time, let it run all day. Didn't care less. Smooth, ran beautifully. And went back to the customer. What do you think happened? Went mental again. The detector went off. Question. Do you think I think it is the detector? What's the chances? This is what you have to put up with. Now, imagine if that was a modified detector and the same thing happened. And you get that comeback. And it's nothing you've done. Who knows what it is? The guy said he put on different coils and all sorts, did the same thing. The only thing I can think of is different is what battery is he using? Is it one of those silver boxes with those audio switching op amps that blow up all the time? Those things in there. Has anyone thought to ask, do you take your mobile phone with you when you go prospecting and leave it on in areas where it's polling all the time? Have you got any other electronic equipment? Do you have a pacemaker? Do you have a HF radio backpack on? I mean, endless questions can be asked. How do you fix this problem? How do you fix it? Anyway, I think Dave's going to get it and it's going to go detecting with it. And what do you do then if you go detecting with it and it just behaves beautifully? And the customer is obviously experiencing this because it's happening to him. And I can't reproduce it. No way known. I can't make it do what it's been said to do. David couldn't do it either. David had it for ages too. And, second time round, I got it. So deep dive, nothing, no problem. Anyway, enough of that. That's been probably a very long video. But yeah, because I haven't got, I've got some technical stuff, but I can't show it just yet. I can't show it. Got to do things in the right way. You can't have other people say, "Oh, I did that first," or something like that. Because I don't like showing stuff when it's not completed. I want to complete it, really. Like that other coil I did, and it was powering over everything. I don't really want to show stuff like that because what'll happen, don't you? I've said it before. You show it and it turns up. Yeah, like lots of things. Lots of things happen. So anyway, guys, think about all the issues in current detector design with all the capacitance. I don't know if any of you want to play around with making an optical receiver input. All you need is optical transmitter and optical receiver that pump it up at the send end so you get over the noise, buffer it, and just bring it back down. Basically, you could probably use some sort of optical compander. I don't know if they exist, do they? Where you overemphasize transmitter and de-emphasize the receiver. We used to do that to get lower noise on HF transmissions years ago. And also, we have done that using analog comms on satellites. Work that one out. Who the hell would use analog comms via satellite? I'll leave you to ponder that. But long time ago too, not recent. I don't do this stuff recent. I'm down in the dregs of DC, which is called metal detectors. It's all low frequency slug stuff. But the funny thing is, though, you really think, from when you're like 14 years old or something, building crystal sets, and like I used to build crystal radios, crystal sets, transmitters, receivers, FM transmitters. Got in trouble once for that. Another story. But yeah, had my own broadcast station when I was 15. Had the radio inspectors come around, who knew my dad very well, but we just had a bit of a talk about that, and it went off the air. Yeah, all this low frequency stuff, and it's gone right up, from the days of building stud finders and, ultrasonic sensor lights and stuff like that. Oh, dear me. Yeah. Oh, dear. But, all the way up into microwave and then all the way back down into the dirt. Well, basically, very low frequency stuff anyway. So, I never thought that I'd ever play with ferrite rods again. But, yeah, like I said, I made that powered pinpointer. Actually, I got a better idea for powered pinpointers, by the way. I'm working on something now. Don't go the old ferrite rod coil thing, just winding it, and hopefully it works. It's those rods are inefficient for a start. They're not made for the frequencies we use with our PIs. But yeah, they do have losses. There's better ways of doing it. You've got to be clever. You've got to be clever and think outside the box. But yes, shortly we'll have some good stuff. And when we have the good stuff, it'll be up on the website. And if you're interested, you can buy it. And if you're not interested, don't. And yeah, I'll just keep moving on making stuff. I've actually done a small change to our boosters, by the way. And anybody who has one of our boosters, I'll show you this. Now I've got to unplug it all. Hang on, I've got one here and coming up. Hope you can't see what was all over my bench anyway, no big deal. Okay, I'm going to point this out. Hopefully you can see this. Okay. Well, it has to be a wire over it, doesn't it? Hiding it. Okay. It's got a wire over it where I've pushed it back, so I'll use one of these and I'll get that off. I know a few of you guys have got these boosters out there. It's basically the same configuration. Okay. I hope you can see that, but on the audio output stage here, okay, there is a gain resistor right there. Okay. Some people want more audio out of these. I did these in a particular way to avoid people blowing their eardrums out. Okay. It's got plenty of grunt. The thing will run 3 watts, but I was going to put provision in there for it, but I've had people say they want more out of it. They want to crank the audio up and run less threshold. And for a speaker, no problem. Headphones, unless you're running our headphones that we designed, great. It won't do it to you. Actually, guys, if you're worried about damaging your ears, get a pair of the headphones I designed. Well, basically, David did the ergonomic part of the whole headphone system. I did the driver and balancing circuitry for the headphones. You should not be able to damage your ears because of the way they work. But you can oomph it so you can get big signal level from a low threshold, but it's not going to go up here and suddenly you've got the hi-fi system on your head. It won't do that. So they're very crisp, and the headphones null out everything else. Like, you know, when you walk through the bush, crunch, crunch, crunch on sticks, don't hear it. But if someone came up behind you and went, oi, you'll hear them. So that part of it's safe. Or you'd hear a bull stampeding behind you or something. You'd know about it. But all tree rustle, stick stones, banging, crunching around, distractions, gets rid of it all. Anyway, here, right there, surface mount resistor. You can change the value on that resistor there. I think it's might be 39k, 39,000 ohms sitting there, something like that. You could take it up to 100k or so. You could take it up to a meg if you wanted to, but don't do it because it's stupid and it'll bring heaps of hiss because the gain will be too much and it'll sit there going like Sammy the Snake, right? So you could probably take it to about 100k. That won't increase the hiss because I actually have a noise filter incorporated into this, which is it's basically a hiss filter. It's a wideband filter, but it's on the top end where all the hiss happens. It doesn't affect the sound. You take it in and out when you got audio, and you can put audio through on and off. It makes no difference to the tonal quality of the sound. But if you want to put the volume up and listen to the background, you don't want to listen to hiss. With this, it doesn't hiss. You don't hear it. But increasing the gain by changing that resistor there, you can do it if you want. And it'll have the same gain profile on the input stage of a rooster booster, if you know what a rooster booster is. It lifts it that much, but you don't really want to put it too high because it defeats the purpose. I'm trying to get this thing so you don't have any, annoying noises. You don't want to hear hiss. You don't want to hear anything except for your target signal. But there are people out there who did make mention that they wanted a bit more oomph on it because they use speakers. You can change that there. Just 100k. I think that's fine. If be it on you if you use headphones, right? But if you're going to take it up too far, you could experiment, but you will get hiss. You start putting capacitors across it to get rid of hiss, you'll stuff the whole audio profile. Don't do it. I took a long time to work this thing out. And you got to remember too, this thing runs expansion and compression on the audio as well. That's why it's got volume, which is that one. Or it's even got a red LED. It draws 0.5 milliamp. It's not going to flatten the batteries. And you get your volume, and you've got your expansion and your compression all in one. So it's like a compander system all in one. It's rather unique how it works, actually. So that's that. And like I say, because this one I've just got in parts, runs on 2 batteries. I was going to make another one up and put a dare I say, put a lithium battery in it and charger and put a C connector on the back of it, because I have these boxes without the battery compartment. So if you are interested in a rechargeable one, booster that you can charge any way you want. And I think USB-C is the best way to go because it's everywhere now, and it's auto sensing as well. So we could put a USB-C charger in it, lithium battery, and on a lithium battery, you could even with these two Vata cells, right? I've left this on, forgot to turn it off. Been on week and a half, not flat, still works fine. But I suppose if you've got audio blasting out of it at 3 watts all day, it will definitely chew the batteries. But as this is, just with a background tone, it lasts for days. It's amazing. Very efficient circuitry in that. And it all works on 3 volts. It'll work on 2.7 volts, by the way. So that's why when the batteries go flat, that's why I like it. That's why I use it myself. If the batteries do go flat and you don't realise you're a bit of a dunderhead, what happens? You turn it on, and first of all, you know the battery are going flat because when your detector turns on, it makes its horrible beep noises or whatever it does. It'll draw so much current that this will go into distortion and distort the signal. But when you go back to threshold, it works beautifully. So, and soft signals, which you're looking for, there's no distortion. It still works, and you can probably work for about another 5 or 6 hours before you should really change the batteries. So even when the batteries go flat, you're not caught out. That's why it was designed that way. So it's a booster you don't get caught out with flat batteries with. And like I say, if guys out there, you want me to make a fully rechargeable one, that I think with a LiPo battery in there, I was working it out. I think you could leave it on for about a month and the battery won't go flat. So up to you guys what you want. But yeah, just let's stick one of those in there, one of those things. Or bigger, twice as big. God, I can make it work for 6 months. Gee, it's asking a bit much, isn't it? But can do all this stuff. I mean, they can do a lot of things. I mean, whatever, just ask. Get on my software designing programs and stuff and design it. But there's a lot of things to do. I still haven't got that. I've got the best project ever. I've actually done the design. I've done the prototype. I've had the boards made. I've got 150 boards, and I have not put one together. And it goes on your detector, and it's a damn best thing since sliced bread. It'll be the best thing for some people. And it also has extension capabilities as well to other things. But anyway, like I say, I'm not giving everyone the heads up on that because, monkey see, monkey copy. That's what will happen. And you just cut your own throat by putting it out there before you're ready to launch. Don't do that because you'll come unstuck. Anyway, I hope that I had the camera in the right position. I've got no idea. Maybe half my head's chopped off. I don't know. Maybe I should have had a look. I don't know. Oops, saying low battery. I can't see a thing anyway. Where am I? Oh no, that should have been right. I don't know. Usually I use the front, or is it the front or the back? The back camera, I suppose, if you're looking at the screen. But this time I've used the front camera because of the high resolution. Just look at the Minelab jobs that are there. Anyway, I think that's enough. I've got to turn this around to turn it off. I've got to undo that because I locked it. Damn. So I'll spin around. No, we won't. What have I done? Oh, I've done that as well. Okay, I'll turn around and find the power button. And, oh, look at that. It's my reflection. Catches.